Hello everyone, I'm Dr. Prajwalit Shikha and today I'm going to talk about cellular network. Now let us first talk about the components of a cellular network. In a cellular network, there is a small geographical area which is called as cell. Within that cell, there is an antenna which can serve the purpose of both transmission and reception. Hence, that antenna is also called as a transceiver. There is a small station which is called as base station, which controls all the users within that cell. And the next component is mobile station. So all the mobile phones which are there inside that cell are called as mobile station. Now the base station is further connected to a mobile telephone switching office, where the function of a mobile telephone switching office is to allocate channel to different users, to set up a call, to process a call, to terminate a call, etc. So here the base station serves as an interface between mobile stations and mobile telephone switching office. Now mobile telephone switching office is further connected to public telephone switching network, which is connected to a stationary phone, which is connected to a wired network. Now in the very beginning, how the mobile communication used to look like. So before the invention of cellular network, there were mobile radio communication networks and it was used to serve a particular city. So basically it started in USA, where the mobile radio communication was used to serve different cities. And for that purpose, what were the components of mobile radio communication system in a particular city? So as I told you that it was used to design to serve different cities independently. So here in a particular city, since the area of that particular city is about 48 to 80 kilometers, that was the radius of a particular city. So in mobile radio communication system, there used to be a very high powered antenna which was used to place on hilltop so that it could cover a large area. So the antenna was equipped with very high powered transmitter and very high powered receiver. Then there was one base station connected to the antenna which used to control all the users within that geographical area. But in that case, there was one problem, that for each communication, different frequencies were allotted. So it means that if at a particular point of time 100 users are communicating, in that case 100 different frequencies were required. Now it has become a big problem with the increase in the number of mobile users in the same geographical area, because in that case the number of frequencies since the number of frequencies were limited, hence the allocation of channels or allocation of frequencies to different users has started becoming difficult with the increase in the number of demand. So to deal with this, cellular concept was developed, where frequency reuse is the main highlight. So now we'll talk in detail about cellular network. The big whole geographical area is now subdivided into smaller cells of hexagonal shape. Hexagonal shape was chosen because it used to cover whole area without leaving any gap in between. The size of each cell was decided based on the number of subscribers or the number of population or the number of users within that area. Now the cell, depending upon its size, can be called as macro cell, micro cell, picocell, and so on. Now a cell is defined by its radius. Radius means the distance of the center of the cell to either of the edge. So if this is the center, then this is called as radius of the cell. For a macro cell, the radius ranges from 2 kilometers to 25 kilometers. And for a micro cell, the radius is less than 1500 feet. And if it is a picocell, then further the radius is reduced to a lesser value. A group of cell is called as a cluster. Now each of these cells have low powered antennas installed within each of them. So a high powered antenna is now replaced by several low powered antennas, and each of these antennas serve the number of mobile stations present within that cell. What are the components of a cellular network system? So in a cellular network, we have cell, we have antenna inside the cell, we have different mobile phones which we call as mobile stations within that cell, and there is a base station which controls the communication of the antenna with each of the mobile cells or mobile subscribers or mobile stations, and then each of the base station is in turn connected to mobile switching center, so which is the control center for the base stations, and the mobile switching center is connected to public switched telephone network, which is again connected to the wired telephone line which was invented in the very beginning, which is still existing. Now, if there is a frequency range which is given to a particular cluster, so cluster is a combination of cell where each cell works on different frequency range. So if a particular frequency range is given to a particular cluster for communication purpose, then that frequency range is subdivided into total 7 parts, because there are total 7 cells in this given cluster. So hence there is a term which is called as frequency reuse factor. So in this case, the frequency reuse factor is 1/7. It means that the total frequency is subdivided into 7 parts, and each part is given to each of the cells in the given cluster. So in this case, there are total 7 cells. So hence frequency reuse factor for this particular cluster is 1/7. Now there can be less than 7 or more than 7 cells also within a cluster. Now, as I told you that a very important application of this cellular network is frequency reuse. So how frequency is reused? So as I told you that the geographical area is divided into a number of cells. A combination of cells where each cell is using different frequency range is called as a cluster. So a geographical area can be covered with a number of identical clusters. So this is the diagram. Here in this diagram, as you can see that here the cells are numbered as A, B, C, D, E, F and G. So here total 7 cells makes a cluster. So there is one cluster over here, and adjacent to this there is another identical cluster, and here also another identical cluster. So there are total 3 clusters which are visible in this diagram. Now here all those cells which are marked identically, they are using the same frequency for communication purpose. So here all the A cells in different clusters, they are communicating with their mobile stations in the same frequency range. Similarly, all the cells which are named as B, they are communicating with same frequency range, and so on. So hence this is the concept of frequency reuse, and hence with the increase in the number of subscribers, we need not have more channels or more frequencies, but the same frequency can be subdivided and allocated to different subscribers, and a same number of frequency bands can be allocated to different users in different clusters. Now there are certain problems that may arise due to frequency reuse. So what are the problems? So there are 2 kinds of interference that may arise in this case. These 2 interferences are called as co-channel interference and adjacent cell interference. Now what is co-channel interference? So for understanding co-channel interference, let us first understand what is aspect ratio. So D by R is called as aspect ratio. So if there is a cell, then this is the center of the cell, and this distance from the center to either of the edge perpendicular distance is called as R. And if there are 2 different cells, then the center of one cell to center of another cell is called as D, and D by R is called as the aspect ratio. So what happens, due to small value of aspect ratio, co-channel interference might occur. So low value of D by R, what does it mean? It means that the two cells which are using the same frequency range are placed very close to each other. And the value of R, the radius of the cell is also large. So by increasing the distance between two similar cells and by reducing the radius of each cell, the co-channel interference can be reduced. Now next interference is adjacent cell interference. Now this arises when two different frequencies mix with each other. In co-channel interference, same set of frequencies mix with each other. In adjacent cell interference, two different frequencies mix with each other, and this occurs in case where there are two different cells which are placed adjacent to each other. Like for example here in this diagram, G and F are two adjacent cells. So if there is a mobile phone which is placed here, or mobile station which is here, which is receiving some signal from base station S strongly and from this base station weakly. This may happen that this is sending some strong signals, they are sending signal weakly. In that case, what may happen, it may receive the frequency from this and very weakly from this base station. So this interference happens because of the power difference in sending the signals, and one very important factor over here is use of improper filter. So if in the receiver the filter is not proper, which is not able to filter the frequency which is coming from this base station, then the interference might occur. So hence, by using proper filters in the receivers, this adjacent cell interference can also be reduced. Now next, two very important terms over here which are called as handoff and roaming. What is handoff? So whenever a mobile station moves from the area of one base station to the area of another base station, then handoff occurs. Now in that case, what happens, if the mobile station in cell C, so where the base station of cell C is serving this mobile phone. Now when this mobile phone moves from cell C to cell D, then it comes in the range of base station D. Now this comes under the control of base station in D. Now in this case, what happens, the connection from the base station C must break and the new connection from base station D must happen so that the services would remain continued. Now there are two kinds of handoffs, soft handoff and hard handoff. In hard handoff, what happens, the connection from base station C first breaks and then the connection from base station D happens. So there is a discontinuation in service which the user can feel. This is called as hard handoff. So this happens when first the connection is broken and then new connection is made. In soft handoff, what happens, when the mobile station is moving from base station C to D, in that case, as it is moving, the connection from C is not discontinued, but what happens at the same time, at one point of time, it is connected to both C and D. And when the proper connection with D is established, then C gets disconnected. Hence, in this case, user does not feel any discontinuation in the service, and this is called as soft handoff. You must be feeling now, since you have the idea, knowledge of all this, now when you will use your mobile phone, you may feel such things and you may find out that what actually is happening with your phone. Now next, where there's another term which is very important, which is called as roaming. Now when this roaming happens, so when we move from the area of one service provider to the area of another service provider, or we can say that when we move from home agent to a foreign agent area, then roaming happens. In this case, there are two things which are happening. One is location update and second process is paging. So whenever the mobile station moves from home agent area to foreign agent area, in that case, first of all, location updation is happening in in a universal register which maintains every data. So once location update is done, then the next thing is authentication process. So the foreign agent authenticates the mobile subscriber in its area with the home agent, and this process is called as paging. So these two things which are part of roaming. Now there are two more things that has to be discussed. One is called as cell splitting, and second thing is cell sectoring. Now why we need to further split the cells? As I told you that the cell can be macro cell, it can be micro cell, it can be picocell, and so on. So if there is too much congestion within a given cell, so there is a cluster where we have total 7 cells within that cluster, A, B, C, D, E, F, G. Now if within cell A, whatever area it is covering, cell A is covering, if within that area the congestion happens, number of subscribers suddenly keeps on increasing, too much population is over there, then what is required? So it means that more number of channels are required to provide service to each of its subscribers or each of the users or each of the mobile stations. Then this can further be divided into smaller cells. Now these cells, if it comes in the radius of less than 1500 feet, they are called as microcells, and within each cell again further low power antennas are placed which are connected to different base stations, and those antennas serve their subscribers within that cell. So this process is called as cell splitting. Now this can further be done if, suppose for example in B further the population increases, then again cell splitting can be done and a high power antenna can be replaced by various low power antennas to serve different subscribers within each cell. Now next important thing is cell sectoring. Now to deal with more increased number of subscribers, cell sectoring can also be done. So what is cell sectoring? So to help you understand what is cell sectoring, I must tell you that in how many ways an antenna can be placed within a cell. So an antenna can be placed at the center, it can be placed at the corner, or it can be placed at the edge. So if the antenna is placed at the center, it is called as center excited antenna. If it is placed at the corner, then it is called as corner excited antenna, and if it is placed at the edge, it is edge excited antenna. Now the centrally placed antenna can radiate in all the direction, can communicate in all the direction, whereas a corner placed antenna can radiate only in specific direction, and similarly the edge placed antenna can only communicate in certain direction. Now what is cell sectoring? So cell sectoring is also used to deal with traffic, to deal with more number of subscribers, to give service to more number of subscribers. So how it can be done? So if there is a cell, hexagonal cell, then it can be divided into different sectors. Like here is, if we divide this cell in 3 different sectors where the angular separation between sectors is 120 degree each, and if in each of the sectors, if we place an antenna, sectorial antenna. Now we call all those antennas which are placed at corner or at the edge, those are called as sectorial antenna, because they can serve only in a particular sector, in a particular direction, not in all direction. So we can place an antenna over here which may radiate. Similarly here we can place which may radiate in this sector, and similarly we can place an antenna over here which may radiate in this direction. So these are the sectorial antennas. So 3 antennas are placed instead of 1 antenna. Now there are 3 different antennas, sectorial antennas, which are serving all the mobile subscribers in that particular sector only. So this is cell sectoring. Now this sectoring can be further divided, and it can be done for 60 degree separation as well. So we can have 60 degree sectors. So 60 degree, 60 degree, 60 degree, 60 degree, 60 degree, and this is also 60 degree. Now here the whole cell is divided into total 6 sectors, but now in this case the requirement number of antennas required are 6. So 6 different sectorial antennas are placed which serve the sector. So one antenna placed over here will serve only this sector. Similarly, another antenna will serve only in this sector, and so on. So this way also increased number of subscribers can be given service to, and this problem can be dealt with. So this is only possible with the invention of cellular network technology. I hope this video is helpful for you. Thank you for watching.